for you, and then spend the rest of the period working on some homework and or going over those test prep questions, which we'll then attack with vigor on Monday. What we're going to do for the next couple days, next couple sections, next chapter, is go back and revisit pre-calc graphing, but incorporate calc stuff into that graphing. Okay, so today we're going to spend a good chunk of time talking about vertical asymptotes. No, go ahead, finish. I don't want to interrupt you.
No, I was finished.
You sure?
Yeah, that's fine.
Okay.
We're done.
Well, that's okay. Like I said, I don't want to be rude
Yeah, I
and
know.
talk over you.
I'm done.
Okay, good. Cam, you good?
Yeah.
Okay, good. So let's talk about vertical asymptotes. How do I get a vertical asymptote?
Or a number that was.
Stop talking, Cam. You've done enough talking already. Mary, how do I get a vertical asymptote? Okay, so if I take a function like 3 over x minus 2, we'll call that f of x. Where's the vertical asymptote? 2. Good. Any problem there? Anybody?
No.
No. Good. So we come over here to 2, put in the asymptote. Mary, what can you tell me about that vertical asymptote? Can the function ever cross it?
No.
Never?
Well, like, there's that one, but I forgot. There's like, where's the thing? I forgot how, like a hole or something. I don't know actually.
Can it ever cross a vertical asymptote?
No.
No, never. Now, there are horizontal asymptotes. We'll talk about that later, and you can cross a horizontal asymptote, but a vertical asymptote doesn't work. It gives us a point of discontinuity. We're going to use calculus then to start talking about how this function looks when you graph it. And we want to graph it by minimizing the number of points that we plotted. So for instance, last year when you were graphing this in pre-calculus, how did you handle the activity around an asymptote? You understand what I mean by that term? What happens when you approach this asymptote? And how did you figure that out last year in pre-calc?
I solved x for 1 more and 1 less than what would produce the vertical asymptote.
So if I'm understanding your comment correctly, you would put in 1 and 3.
Mm-hmm.
And then what?
And then graph that point, and then that would show, like, depending on where it is, whether it would go like up or down.
Okay, so let's talk about this. Let's bring some calculus in here. What's a limit as x approaches 2 from the negative of f of x? Which in essence is what you just described, right?
Mm-hmm.
And you just chose to take one integer value less or one integer value greater than. Okay. Well, in that case, what's the answer? Because that's really what we want to know. We only have 2 possibilities. What are the 2 possibilities? Casey?
Infinity and negative infinity.
Infinity and negative infinity. In other words, we need to figure out, does that graph go up or does that graph go down? So John's technique works solid because if you put in 1, you can determine where that point, and you would actually plot that point. Okay, we'd like to avoid that by actually plotting points, and all we want to really know is what happens when it gets close to that value of 2, which in essence is what we talked about with a limit here. Okay. Since this is calculus now, that's too big of a gap. Because, I mean, that's a very basic function, but if the function gets a little weirder, a lot can happen in that distance of just 1. So we want to get closer and closer. How close do we want to get?
Infinity.
Can we do that?
A limit, I guess.
You can approach it.
Okay, so now we're in a circular argument here. Yes, we'd like to get infinitely close. Can we? Well, we need to do a limit. So to do a limit, we have to get infinitely close, but to get infinitely close, we have to do a limit. So what? So how do we do that?
You take
Take a
one
really
side.
Let's go back to John's technique. John, you put in 1 there, what do you get? 1, -3 would put it down here. What does that tell you?
Most likely that'll approach negative infinity
And you know I'm gonna have a problem with that term, most likely, right?
because it's not in every case, so we would have to test it with a different point.
How many points do we have to test?
2 at most.
3, 2?
Like, if you do it between 1 and vertical asymptote, then you would only need to test once.
So this doesn't convince you, what's your gut reaction? Do you think it's gonna be negative infinity or infinity?
Negative.
Negative infinity. Does everybody agree?
Oh, yeah, 'cause it's a multifunction.
What'd you call me?
You heard me.
That's good. That's a good response. Hey, what are you gonna do about it? So you wanna keep plotting points? What would you like to plot next?
Let's do 0.5.
You wanna move away from the asymptote.
Wait, what? Oh, 1.5.
1.5, that's better, because again, that stays with our calculus mentality that we wanna get closer. So at 1.5, plug that in there, what do we get?
6. -6.
Well, that's a pretty good indicator of what's going on.
Mhm.
And we can plot another point, and we can plot another point, we can plot another point. That's way too much work for me, I'm too lazy.
Mhm.
Can we streamline the process? Well, let's pick a point closer. Let's pick that point right there. Where is that point?
1.9.
1.9? Is that close enough?
Sure.
Okay. Is it? Rest of you are okay with that?
It's a little bit.
Uh,
It's a little bit.
What would
Maybe
you,
like 1.99.
wanna throw an extra 9 in there just to feel better about?
Yeah.
Okay.
I feel like that's like a safer.
2 9s?
Yeah, 2 nines.
Okay. What about 3?
I mean, if you really want to go for it.
Well, I don't care. I can, it's fine with me. It's up to you. You wanna do 3 9s?
Sure.
Okay. I'm getting to a point here, no pun intended, and my point is that I only need to know one thing. I need to know, am I gonna get a positive value or a negative value? Because the graph is only gonna do one of two things. It's gonna go up to infinity, or it's gonna go down to negative infinity. So John's strategy is pretty solid there. If we put in a point, all of a sudden having it end up in the below the x-axis is enough for me to see that that function is going to go down to negative infinity. But the problem is that's too big of a gap for calculus. So I'd rather put in something like 1.999. It doesn't matter what number we plug in because I only want to know one of two things. Is the function going to be positive or the function is going to be negative? So there's very little calculation to actually find the values. I'm not actually plugging in points. I'm just determining if the function is positive or negative. So what if I put in 1.99? Is that fraction positive or negative? Why?
It's less than 2, so it makes it negative.
What's it?
The value matters. No, the denominator.
And what happens to the numerator?
It turns negative as a result. Like, since it's going.
So you don't like the negative on the denominator, you want to bring it up to the top.
Well, that's just how I am.
Okay, that's fine. We get a positive over negative, which is negative. That means that this value, as I get closer to the asymptote on this side, is going to be negative, and therefore it's this one, the one in red, that we want, and we want to get rid of this one. Okay, so that's a verbose way of saying we just want to get a value or an idea of the function of whether it's positive or negative. We can repeat that process on the other side. Put in a number bigger than 2, let's say 2.00001. If I put in 2.001, will the function be positive or negative? Why?
It makes the denominator.
Positive over positive gives us positive, and therefore the function will go up. However, we can also use another technique. Have you ever heard the word multiplicity?
Yeah.
What is it?
Simplicity.
Don't worry about it. Fine. Everybody, you should have, I almost threw up last period. I was giving a test to a bunch of freshmen, and the noises that were coming out of them were just they've got the plague, so it's all, yeah.
I
By the
was-
way, you're sitting in all their desks.
Freshmen are so
It's a city.
They should just be hosed down.
Isn't
People should just
With
learn
like,
how to
with like a
calm down.
industrial strength hose that's got Purell in it.
Bleach.
Welcome to math.
Douse them in bleach.
Where were we? Oh, hey, multiplicity. What is multiplicity?
What does it mean?
If we look at this function, I've got that little thing in the bottom that generates the vertical asymptote. Okay, that, let's call it a term. That term is raised to what power? Good, 1. Okay. So that has a multiplicity of 1. Multiplicity refers to the exponent on the term that's generating the vertical asymptote. Does this sound familiar? What if the multiplicity is odd? If it's odd, then we have 1 up and 1 down. If it's even, they either go both up or both down. Good to say. So we can we can go back and plug in a point a little bit bigger than 2 and see that the function gives us a positive value, or we can use the multiplicity. The multiplicity on that asymptote is odd. Therefore, if we determine that the red one is going down, the blue one must go up. And now we've graphed sufficiently around that asymptote. And really, that's all we're focusing on right now, is what is the behavior of the function around an asymptote. And then eventually, we're going to put all these pieces together. And in pre-calc last year, when you would solve problem or graph these kind of rational functions, you would do this kind of thing. You generate the horizontal asymptote, you find the vertical asymptote, you find the intercept. We're going to do that all again, but we're going to incorporate calculus, which will get us virtually a perfect graph. In pre-calc, you have to do some guessing, plotting some points when you don't know how to determine, does that thing look like a U, does it look like a tangent in between? And it'll come back to you as we go. But we'll get a more exact graph as we go along. Okay, so another tool to make your life a little bit easier determining how things behave around an asymptote. Okay, I forgot to mention a term. We had an answer there of negative infinity. They like to use terms, these two terms, increases or decreases. Decreases without bound is a fancy way of saying infinity or negative infinity. Okay, let's look at g of x. And we'll do 1 over x minus 1 squared. We'll keep things simple here. Sam, where's the asymptote?
1.
Good. Okay, tell me about the behavior around 1. Any ideas?
Well, it's even, so it's gonna be on the same sides.
Right, so either both up or both down.
Yeah.
Okay, how do we figure out which one?
Well, we could plug in like 0.999.
Okay, suppose I plug in 0.999. What will I get? And again, the value is not important, the sign is the only thing we care about. Is it positive or negative?
It'll be positive. 'Cause-
Why?
Well, if you get a negative and then you square it, so it'll be positive.
Can I get a negative answer out of g of x? No. That function will always be positive. The numerator is positive. The denominator is always positive, so therefore we know the behavior around this asymptote has to do something like that. Pregunta.
Yeah.
See-
If there's a negative, like, can't you tell whether it's gonna be both up or both down, just if there's a negative sign before the parentheses?
Yes,
Okay.
because that would then force it to always be negative, and they both go down. What's the limit as you approach 1? Well, let me write this for the visual learners in the group. What's the limit as x approaches 1 from the positive of g of x? What's the limit as x approaches 1 from the negative of g of x? And what's the limit as x approaches 1 of g of x. Caitlin, what's the first one? So I approach from the right. What does it go to?
Infinity.
Good. And from the left? And at 1.
Doesn't
Anybody disagree?
Yeah.
Why?
Because left hand
Because
is
it's infinity.
If both are
No one disagrees with her?
I disagree.
I disagree.
I disagree.
Sorry, no one agrees with her is what I meant to say. You do agree?
Yes.
Okay, so, Caitlin, do you wanna make an argument for why it does not exist?
No.
It, it just came to you in a dream, or where'd that,
I don't know. I just thought it didn't, but what they said makes more sense.
you wanna switch camps?
I don't know.
It's just you and John in your camp, and you're leaving camp and leaving John alone?
John.
No, Kevin's in
I'll
that
stay with
camp
John.
too.
No, not anymore. I was on the quiz. I was, yes.
24 hours ago, you were in the camp, and now you packed up and left. Awesome. So if I understand these correctly, John's the only one that agrees with does not exist?
Like, I could also see why it would be, but like, infinity is not. I agree with John.
The
Are you
definition.
deserting your own camp, John?
Could
No,
it be
I'm
both,
just
though?
recognizing both camps.
Oh,
But
Like,
Like
I have
double
one leg
agent.
in one leg in the other.
I understand. Sitting around both campfires at the same time.
Yeah.
singing
Could
kumbaya.
It's really warm.
Can it be both?
Like depending on how you would.
That's a pretty safe answer, so you don't wanna make a decision, you're just gonna go.
Well, yeah.
You wanna be friends with both people?
It's
Can't we all just get along?
stay with it.
Alright, for those of you who are saying no, why infinity? Cam?
Because the definition of a limit is the number that you approach at that x value, so you're approaching infinity at that point.
But
Oh, John's starting some stuff again. What'd you say?
infinity
It's a
is the
value,
number.
bro.
Infinity is
Well,
not
not a value, it's
It's not a
it's
number. Didi?
Don't like discontinuities don't like count when you're doing limits, like they don't, like you can have like something that doesn't continue, but like it doesn't necessarily add into what the limit is. Cause like holes you can still have like.
Wait, now you're confused. We're talking about two different things. You
I
wanna
know,
talk about
like,
continuity,
so
or you
no,
wanna talk about
No,
limits?
so continuity, so like an asymptote has a discontinuity,
Correct.
but it's like what Cam said, that you're still approaching that limit. So even
Uh-huh.
if there's like a discontinuity, even though there isn't necessarily a point there, you're still approaching what one is.
Like it's
It's
gonna.
So you're arguing for infinity.
And
Yeah.
limit and the
Okay.
sky is infinity. The sky's
Well, I don't have an answer for you.
Why not?
I'm with John, I'm in both camps. Okay, this makes sense to me because infinity is not a number, so therefore it's not actually approaching any one number. And I can buy into that. This, to me, personally makes more sense. Left-hand limit is infinity, right-hand limit matches or goes to infinity. One of our definitions of have a limit at a point is that the left hand has to match the right hand. We have infinity. Now the important question is, what does the College Board recognize? And they're a bunch of namby-pambies, and what they do is they avoid the discussion. I have never seen a question on a test that involves this scenario. So instead of discussing it, or giving you credit for both or drawing a hard line, they just say, let's avoid it altogether. Yes, Sam?
What was that on the quiz?
What are you asking me? Which one did I give you credit for?
Yeah.
Well, there's three possibilities. This
Oh,
one,
no.
well, there's four possibilities actually.
All of them.
This one is correct, this one is correct, they're both correct, neither is correct.
Oh.
They're all correct.
All correct?
So unless you put 4 in there, you've got a good chance.
Unless-
Four would be a little off, yes. I actually accepted both on the quiz.
Woo!
Will you continue to?
Well, you know, and sometimes, the other sneaky thing that the College Board does is they'll throw in things like, what number does g of x approach as x approaches 1? So they'll make a small little comment in there. We're just splitting hairs here, and either one is okay. I'd accept either one, okay, in this case. Now, if it goes the other way, If you've got this one going on, there is only one answer, and that does not exist. Okay, but this is the one where they're both up or both down. That can get a little funky.
Get it? Cause it's a function.
Say again?
It's a funky function.
They kinda sound alike.
It's an alliteration.
I'm just gonna move on.
I mean, it's kind of an
Wait, are we recording this?
Yes, we are, unfortunately.
alliteration, but like,
I'm sure Cam will be listening to himself over the weekend.
alliteration is like the, like.
No, someone
Talk
brought
about
up to me
funky
in the
functions.
conversation that they could hear us talking about the grapes.
I'm sorry, what?
Someone brought up to me that they were watching the thing and they heard our conversation about fitting 20 grapes in your mouth.
Those kind of
Wasn't
things.
really much big conversation, you have 20 grapes in your mouth.
So cute.
Yeah, he wasn't talking. All right. That having been said, where are the vertical asymptotes? Sydney.
No, I'm just saying.
Technically speaking, we would have x equals 1 and negative 1 because they are lines, but that's great. Perfect. Okay, let's talk about the behavior around each one. Which one do you want to do first, Sydney? -1. Okay. And you want, let's start all the way to the left and we'll work our way to the right. What happens to the left of -1? Is it going to go up or is it going to go down? While you're thinking about that, let me help out here and do this. Which is where I assume you got the 2 asymptotes, right?
Yeah.
Okay, good. Now the key here is if we can get one of those, we can pretty much work the rest of them out by looking at the multiplicity and doing some sneaky stuff. So what did you say to the left of -1? Up or down?
Oh, I don't know.
Okay. Abby, can you help her out?
Up,
Why?
because it would be positive on the top and positive on the bottom.
Okay, so
Do you just plug in?
Plug in negative.
I don't plug in, I mean, I'm plugging in numbers, but I'm not looking for values. I'm just looking for signs, which I think is a lot easier. So for instance, as Abby mentioned, the top is always positive. Do we agree? Okay, x squared is always positive. You add a positive number to a positive number, it's always going to be positive. If I put in a number less than -1, like let's say -1.1, what is this going to do?
Be negative.
Negative. What's this going to do? Negative. Negative times a negative is positive. We have positive or positive.
Mr. Reed, so when you do ones like this, do you always have to plug in what like the first value is? So like, I'm trying to explain this. So if you have like a negative number in the first, like in the x minus one, you have to put the same value in the second one.
Yeah, you got to do them all at once.
What if it was flipped? So if you have like x plus 1 first, you so it always have to go with the lowest value you have to put in.
I don't know if I understand your question.
So like, if x plus 1 was in front of you, say like something lower than x plus 1 would just be 0.99. But then it never mind. I
And
talked
that's,
myself through it.
okay, good. Glad I could help. All right, Sydney, back to you. If this one's up, what's this one doing? Why?
Because it left in 0 and it goes down.
You plugged in 0? Okay, and you got what?
Like negative.
Negative.
It's like positive or negative.
But 0 is halfway between -1 and 1, so is it this one or this one?
Both.
They're both down?
Yeah, it's like a U.
Ooh,
It's a
look
front
at you getting all sneaky there. So you're gonna argue that we're gonna have that.
Yeah.
Okay, let's roll with it. Then what's this one? Up or down? Up? Why?
Because it's opposite.
Because, but why is it up? How do you know that?
It's odd.
Good. What's it?
The
Mul-
X,
the
yeah,
multiplicity?
is odd.
I'm with you 100%. The only one I'm a little shaky on is this one. This one would be down because of the multiplicity also.
Okay.
But I'm a little bothered because 0's smack dab in the middle.
So try.
Okay?
Can you do like negative half and then positive half?
Sure. But again, it's calculus, so let's do 0.99. Because that's just right. Instead of coming all the way over here, I'm going to do right there. That way there's no problem with this asymptote. I'm just strictly facing this asymptote. So if I put 0.99 in there, the top will be positive. 99 in there would be positive or negative? Negative. And put 0.99 in there, we get positive. Positive times a negative is negative. Positive over negative is negative. So in fact, you were correct. Good. What we're going to do later is fill in all those gaps in between what happens at the asymptote. So we're going to figure out what's happening as you move further away from here and further away in this direction. So that direction, that direction. That's actually Monday. And then we'll also figure out what's going on in here. And you said it looks like that parabola thing. So you remember from pre-calc that we get that kind of curvy thing in there, which is more than likely what that does. In pre-calc last year, you sometimes had trouble finding that point. Where did it turn? Okay, here we can find it because it's a y-intercept, no problem. But eventually, in this class, we're going to figure out how to exactly figure out where that point is using some calculus. But that's many weeks away. Okay. We good? Good. I don't want to make a mountain out of a molehill. I just want you to understand finding how the asymptote and then being able to determine the behavior on both sides of those asymptotes is what we're looking for. Doing a minimal amount of work. Yes, you could plug and chug numbers till you're blue in the face. But if you're sneaky about it and you use multiplicity and you look at just the signs, these behaviors get to be fairly easy. Okay. Questions about any of that? I think most of this is review, but incorporating the concept of limits into this is what would make it a calculus-based thing instead of a pre-calc. Now let's talk about one more, just because life would be complete without some trig. Let's call that P of x. Where are the asymptotes for cotangent? That's tangent.
Pi and 2 pi, or 0.
0. Is it just 0 plus 2 pi k?
Say that again, Casey.
0 plus or minus 2 pi k.
Pi.
Pi k. Period's pi for cotangent.
Oh, what did I say?
2 pi k.
Oh.
And then this would continue over here to 2 pi. Now, depending on how you graph the cotangent, you might have just memorized that it's the opposite of tangent. So in other words, tangent goes like this, so cotangent has to go the other way. Or we can use what we just talked about with this concept of finding the values using limits. So what happens when I get very close to 0? When you get very close to cotangent, first of all, cotangent is undefined at 0. But as you get very close to it, the number gets very big. Why does that happen? Well, we have a fraction here that's cosine over sine. Plug and chug 0 into that, I get 1 over 0, which is no good. But as I get very close to 0, the sine value is getting very close to 0. Okay. So this denominator is getting very small. In fact, it's approaching 0. What happens as a denominator continues to approach 0? What happens to the fraction itself? Bigger. How big? Good. It gets infinitely big.
Pretty big.
Okay, yeah. So that goes like that. This goes like this, and then you'll recall from cotangent we have something, well, that's horrible. Something like that.
Yeah, definitely just one
Like stick.
We will talk a lot about this idea of taking a fraction and looking at the values of the fraction when you play with the numerator and the denominator. So for instance, if b is a constant and a gets very, very large, what happens to the fraction?
Very, very big.
It gets very, very big. What if the denominator of that fraction gets very, very big? What happens to the fraction?
Very, very small.
And approaches what?
Zero.
0. Good. And then you can talk about the relationship then, what happens if the denominator gets very big or very small? What if the denominator goes to 0, but doesn't actually get to 0, it gets very close to 0, and the fraction gets very large? And that whole concept of looking at limits of the